Well, hello, math nerds. This is it, the last video ever of Math 0028. This is your practice final exam. So there will be 33 questions on the final. They are multiple choice. It will be taken in Canvas so that you'll know kind of what to look for. And so we got 33 questions to get through. So let's get started. Number 1, we want to solve this equation. Negative 10 equals 9 plus x. So to get the x by itself, we need to subtract the 9 from both sides. So negative 10 and negative 9 is negative 19. That comes down. The 9's cancel, and we have x. So there's your solution. Number 2, to get the x by itself, the first thing we need to do is get rid of the negative 9. So I'm going to add 9 to both sides. So 4x is going to come down. The 9's cancel. Negative 17 plus 9 would be negative 8. And then divide by 4 on both sides. So the 4's cancel and x equals negative 2. Number 3. You've got variables on both sides of the equal sign. The 7x and 9x are on opposite sides. So I'm going to move my variables to the left, just like we've done before. So I'm going to start by subtracting 9x from both sides. So the 7 comes down. 7x minus 9x is negative 2x equals 19. That comes down. The 9x's are gone. So now if you look at the equation, you need to get the 2x term by itself, so we have to get rid of the 7. So you subtract 7, make sure you subtract it so that those cancel. Negative 2x comes down, and 19 minus 7 gives you 12. And your last step is to divide by negative 2, so x equals negative 6. Alright, on number 4, we're going to first of all have to distribute to get rid of those parentheses. So 12x comes down, and then we're going to take negative 2 and distribute it through the parentheses. So that's going to be negative 8x, and a negative 2 times negative 6 is positive 12, and then bring down equals 24. Now on the left side we have like terms, so you just combine them exactly the way they're written. 12x minus 8x would be 4x plus 12 equals 24. So we have to get rid of the 12, so we're going to subtract it from both sides. So 4x comes down, the 12's are gone, and then 24 minus 12 would give you 12. And then divide by 4 on both sides, so x equals 3. Alright, number 5, you have to be careful on this one because what you're distributing is going to be like a negative 1 in front of those parentheses, not the 7a. The 7a just comes down, and we take negative 1 and distribute that. So that's going to be negative 3a, and negative 1 times negative 2 is going to be a positive 2, and then equals 14. So 7a minus 3a on the same side, that's 4a plus 2 equals 14. And now we need to get rid of the 2, so I'm going to subtract it from both sides. So 4a comes down, the 2's cancel. 14 minus 2 would be 12. And then divide by 4 on both sides. And so a equals 3. Alright. Number 6, we have fractions. So this is the problem where you want to look at the denominators and figure out what your least common denominator is. So we have 3, 6, and 2. So the common denominator is going to be 6. So this is where we put 6 over 1, and you're going to multiply it by every term in the whole equation. So I'm going to leave that minus sign hanging out there in the middle. 6 over 1 times 5 over 6. And then 6 over 1 times that negative 1/2 on the other side. So on the first set of fractions, the 3 cancels to 1, and 3 goes into 6 2 times. So we have 2 times 2 would be 4x. bring down the minus sign. On the second set, the 6's cancel to 1, so 1 times 5 is just 5. And on the right-hand side of the equation, if we cancel by 2, you're going to have 3 left at the top, times a negative 1 would be negative 3. So, much easier. That's the whole idea, getting rid of all those fractions. Now, we're going to add 5 to both sides. So 4x comes down. Negative 3 plus 5 would be 2. Be careful. So many people screw up at this step. Divide by 4. And 2 over 4 is not 2. That is a fraction. 2/4 reduces to 1/2. So be so careful about that, because a lot of people make a common mistake there. All right, number 7 is a proportion. So we are going to cross multiply. And I'm going to put the term with the variable on the left side. So we're going to have 3 times n minus 7 equals 4 times 6 on the other side. So we need to distribute the 3. So that would be 3n minus 21 equals 24. Okay. Now we need to add the 21, get rid of that constant, plus 21. So 3n comes down, the 21's cancel, and we have equals 45. Divide by 3, and n comes down, and it equals 15. Okay, number 8 says translate into an equation and solve for x. The difference between 8 and twice a number x is 4. Okay, so we've got keywords here, difference, twice, okay, and is, that is an equal sign, okay. So difference is subtraction. So we know we need to have a subtraction sign between 8 and twice a number. So the first thing you need to do is put 8 there, okay. So the difference between that and twice a number. Twice a number means 2 times, so 2 times x, and then is your equal sign, 4. So that's the equation that we're going to solve. Okay, we're going to start by subtracting the 8 from both sides. The 8's cancel, so negative 2x comes down, and 4 minus 8 is negative 4. Then divide both sides by negative 2, and x equals positive 2. All right, number 9, we have an inequality to solve. So our first step is we want to get our variables together on the same side of the inequality sign. And I'm going to definitely move these to the left. So I'm going to subtract 5x from both sides. So what's 7x minus 5x? That's going to give you 2x. Plus 7 is greater than, 5x's cancel, greater than negative 1. Now we need to get rid of the 7, so subtract 7 from both sides. Excuse me, 2x comes down and is greater than negative 8. And then divide by 2 on both sides. Now, this problem didn't have it happen, but chances are the one on the final exam, you may have one where you have to divide by a negative, and if that happens, you have to remember that you have to flip your inequality sign. This one does not flip because we divided by a positive 2, so it stays as greater than, and we get negative 4. Okay, 10 and 11, we're now getting into exponent problems with polynomials. So 10 is just addition. This is where you're going to put the second polynomial up underneath the first one so that like terms are on top of each other, so that you've got them lined up. So we have x squared plus 4x squared would give me 5x squared. And this is a 1x, and negative 15x would be negative 14x, and 1 plus 9 gives me positive 10. So that gives you your polynomial in descending order. Number 11, what you have to be careful of here is because it's subtraction, we're going to change this. We're going to do keep, change, and take the opposite of everything and the second polynomial. So the sign in the middle is going to become plus, and this is going to become positive x squared. This is going to become negative x and positive 3. So if you want to, let's do this one horizontally because it doesn't line up very nice. The biggest exponent is the x to the third. So negative 9x to the third just comes down. There's no other x cubed. Then the next exponent down is positive x squared. There's no other x squared term, so you just bring that down, plus x squared. Now look at what you have for the x's. You have positive x and negative x. Those cancel out completely. Okay, so be careful there. And then we have negative 1 plus 3 would give me a positive 2. So that would be your answer there. All right, number 12. Now we're getting into more of the exponent problems where we have to remember the rules. So, 5 exponent rules. When you multiply, you add the exponents. When you divide, you subtract. When you raise a power to a power, you multiply. Any negative exponents go to the bottom. If they're negative on the bottom, they go to the top. And anything to the 0 power is 1. So make sure you go back over those rules and remember those exponent rules. So number 12, you're multiplying. So we're going to multiply the coefficients. 3 times negative 7 is negative 21. And then add the exponents on the a's and b's. So on the a's, we're going to get a to the third. And on the b's, 2 plus 9 gives me 11. All right, and that's it for number 12. Number 13. This is raising this product to a power. So the first thing you need to do is put in a little 1 on the 3 and a little 1 on the y. And you're going to distribute the 2 on the outside to all the exponents on the inside. So you're going to multiply the exponents. So 1 times 2, you're going to have 3 squared, x to the 4th, and y squared, because you multiply all those by the 2. And then the last step you need to do is multiply, work out 3 squared, which is 9, x to the 4th, y squared. Okay, number 14. This is a division problem. So the rule is subtract the exponents. So 6 minus 13 is going to give you a to the negative 7. Well, if it's a negative exponent, it has to go to the bottom to become positive. So when you put it on the bottom, that a to the 7th, the 7 becomes positive. And just remember, some people are like, well, how do I know if it goes to the top or bottom? The thing is, when you subtract, it's kind of in limbo. If it comes out positive, it goes top. If it comes out negative, it goes to the bottom. Also, look at your exponents to begin with. 6 on the top, 13 on the bottom. Your answer had better end up where the bigger exponent was to begin with. The 13 was on the bottom, so your answer, the a, had better be on the bottom, which ours was. So that's good. Number 15, 7 to the negative 2, you have to put that to the bottom, 1 over 7 squared. And then you need to work that out. 7 squared would be 49. So your answer is a fraction, 1 over 49. All right, number 16. Ooh, this is a pretty rough one. Before we do anything with the first parentheses, we're not messing with that. We need to deal with the exponent on the outside of the second parentheses. So for right now, just bring down negative 2ab to the negative 2. That just comes down, okay? On the second one, we need to put in little ones because we're going to distribute that negative 2 to all the exponents on the inside. So we have 4 to the negative 2. When we multiply the a's, negative 2 times negative 2, we get positive 4, and on the b, we get negative 2. Now, the hardest part of this problem is 4 to the negative 2. That's where everybody messes up. This negative 2 on the first parentheses is to the first power. It's staying on top of the fraction, okay? Now look at just the coefficients. The negative 2 stays on the top. 4 to the negative 2, that's a negative exponent. It has to go to the bottom to become positive. Okay, that's the hardest part. Now look at your variables. The rule is we're multiplying, so we're going to add our exponents. So I'm just going to write them out to the side here. That's going to be 1 plus 4 on the a's, so that would be a to the 5th. And on the b's, we have negative 2 and negative 2. You add and keep the sign. That would be b to the negative 4. So here's the deal. You have negative 2. We can go ahead and work out 4 squared on the bottom. That's 16. And look at your variables. A to the positive 5, that's got to go top. B to the negative 4 has to go to the bottom to become positive. So you have A to the 5th on top, and B to the 4th, when it goes to the bottom, remember it becomes positive. Now, your last step is you can reduce those two coefficients out front by 2. So that's going to give you negative 1 A to the 5th over 8 B to the 4th. And remember, when you're putting answers into WebAssign, it does not like you to write that coefficient of 1, so you would just have negative A to the 5th over 8B to the 4th. You can leave off the 1. You cannot leave off the negative. If you leave off that negative, it's wrong. So be careful. All right, number 17. This is a lot of multiplying, because what you're going to do is you're going to take 4x and you're going to multiply it by every single term in the second parentheses. Okay, so let's look at doing that. So 4x times x squared is going to be 4x to the 3rd, because remember you add your exponents. And then 4x times negative 3x is going to be negative 12x squared. And 4x times 2 is positive 8x. All right, we're done with the 4x. Now you go back with negative 2, and you're going to multiply negative 2 times all those terms. So we're going to get negative 2x squared. And negative 2 times negative 3x would be positive 6x. And negative 2 times 2 would be negative 4. So you just have this big long list of terms. Now you want to combine like terms. So your biggest exponent is x to the 3rd. There's no other terms that match that. So that comes down, 4x to the 3rd. And now you've got negative 12x squared and negative 2x squared. So you combine those. Negative 14, you're going to add and keep the sign, and it stays x squared because you're combining like terms, which means your answer better be like what it started. And also, if it's going in descending order, you wouldn't add those and get a 4 there. That wouldn't be going down in order with your exponents. So that's why it has to stay the same. And then we have 8x and 6x. Those are like terms. That's also going to give you 14, just plain old x, and then minus 4. So just be real careful about combining your like terms. All right, number 18 and number 19. These are both FOIL problems, okay, because you're going to be multiplying binomials. We're going to do b times b, that's b squared. Then b times 6 would be positive 6b. Now we go back with the negative 8 times b, that's your inner term. That would be negative 8b. And the last, negative 8 times 6 would be negative 48. So bring down b squared. 6b minus 8b would be negative 2b, or not 2b, a little bit of Shakespeare, minus 48. And that is your answer. Now, number 19 says expand and multiply. So what they mean by expanding, because it says to the second power, squaring it, is what you're going to do is you're just going to write it twice. That's what's considered expanded form. But just because you write it twice doesn't mean you're done. You also have to multiply. So x times x is going to be our first term, x squared. The outer term, x times 5y, would be 5xy. Then you have your inner term, 5y times x would also be 5xy. And now be careful, 5y times 5y is going to be 25, because you multiply the 5's, y squared. Be careful about that y squared. So, when we combine, x squared comes down, but you've got like terms here, 5xy and 5xy adds up to positive 10xy plus 25y squared. Okay, number 20, we're going to divide. So this is where you take the term that's on the bottom and you're going to divide it into every term on the top. So remember your exponent rules. When you divide, you're going to subtract those exponents, but you actually divide the coefficients, the big numbers out front. So 56 divided by 7 is 8. If we subtract the a's, you're just going to get a, but the b's cancel out. They're gone. Okay, then we go to the next term. Minus 14 divided by 7 is 2. The a's cancel, and so do the b's. So the middle term is just 2. Bring down the plus sign. 49 divided by 7 is 7. A over A cancels out completely. And if we subtract the b's, 2 minus 1 just leaves b. So that's your answer for number 20. All right, 21, we're now getting into factoring problems. So you want to remember your checklist. The greatest common factor, perfect squares, can't draw a square, go to FOIL, like trial and error, and if it's got 4 terms, you're going to group it. So look at 21. You have a common factor of 6y. Okay, so if we divide both terms by 6y, the 6's are going to cancel, and we get y to the third when we subtract, minus 3, because 18 divided by 6 is 3, and the y's cancel. So we just get y cubed minus 3 in the parentheses. But if you don't have the 6y out front, it's wrong. That's the whole idea there. Okay? Now, number 22. Look at how many terms you have. You have 4 terms. So we want to try and group this. We're going to put parentheses around the first 2 and the last 2. So look at just the first 2 terms. X squared is going to be your GCF there between those 2. So when you go back and divide x squared into both terms, you're going to get y plus the 7 comes down, those cancel. Okay, so we have y plus 7. Bring down that plus sign. Okay, in the second 2, 3 is your common factor. So write that out front, but then make sure you go back and divide it into both terms. So we're going to get y plus 7. So the y plus 7's being the same there in the parentheses, that's how you can tell that you're on the right track. So that comes out front, that's your GCF, y plus 7. And your leftover, start at the left side, would be x squared plus 3. So when you're done with the grouping, you should have, your answer should look like a FOIL problem. So be careful about that. Okay, number 23. There's no greatest common factor. We don't have perfect squares on the ends. A squared is a perfect square, but 12 is not. Okay, so this is just plain old FOIL. Okay, so since we have a squared, we're going to put a and a. Now we want the factors of negative 12. So if you think about negative 3 and 4, or maybe negative 4 and 3, the very first term, set of terms, negative 3 plus 4, would give me a positive 1. And that's what we want because that's what's in front of the a there. So you put in minus 3 and plus 4. Okay, and that's it. Now look at 24. Is there a greatest common factor? No. Perfect squares? No. 4 is a perfect square, but 14 is not. So this is trial and error. This is where we're going to have to find the factors of 14 and 4. So 14, I have 1 and 14, 2 and 7. 4, I have 1 and 4, and 2 and 2. So for 14, I want to try 2, and you have to put a t with it, 2t and 7t. That's what I want to try there. Now here's the problem. If I try and put 2, use the 2 and 2, I can't put the 2's in the same parentheses. That won't work. But if I used 1 and 4, that might work because they don't have any common factors within the parentheses. Now remember your sign rule. If the last term is positive, the rule is you go to the center, to the middle term, and whatever that sign is, that's what you use in both. And now we have to check the outer plus the inner, the OI. So multiply 2t times negative 4 is negative 8t. and the inner term, negative 1 times 7t, is negative 7t, and that adds up to negative 15t. So it works. So that FOIL right there, that's your answer. All right, number 25. We do not have a greatest common factor, but we do have perfect squares because a squared is a perfect square and so is 64. So we set up FOIL, and the square root of a squared is just a. The square root of 64 is 8, and the signs are going to be opposites. Okay, and that's it on that one. Number 26, we want to solve this, and so this is a quadratic equation. So this is where you have to have two things. It has to be in descending order and it has to be equal to 0. Well, it's in descending order, okay, because the exponents are going down in order, and it's equal to 0. So our next step is to factor. So we don't have a GCF, we don't have perfect squares, but we're going to factor, set up FOIL to factor this, okay? Make sure you keep it equal to 0. So we're going to put in x and x. Now, think about the factors of 15. You have 1 and 15, 3 and 5. Well, 3 and 5 will add up to 8. So we put those in, 3 and 5. And remember your sign rule. Last term positive, go to the middle. They're going to both be negative, the same as the middle sign. Now, here's where everybody messes up. You're not done. This is where, because it said to solve, so you have to take each factor, x minus 3, set it equal to 0, and x minus 5, set it equal to 0. So add 3 to both sides of the equation. So x comes down, and it equals 3. And over here, add 5. So x comes down, and we get 5. So when you put your answer into WebAssign, it's just going to be with a comma in between, 3, 5, like that. Okay? All right, number 27. The biggest problem that people have here is that they want to try and cancel before they even start. You cannot cancel those x squares. So the whole deal here is you have to factor the top and bottom separately. So the top, we've got perfect squares. We don't have a common factor, but we do have perfect squares on the ends. So if you look at that, the square root of x squared is x, and the square root of 16 is 4 and 4. Now you do need to make sure you double check this to get that 8 in the middle. The last term's positive, so they're going to go to the middle. They're both going to be plus. Now if you check that, the outer term is 4x, and the inner term 4 times x is also 4x, which gives you 8x, so you know it works. Okay? On the bottom, we don't have a GCF. 24 is not a perfect square, so we're just doing plain old FOIL. Okay, we're going to put in x and x. Now we need the factors of negative 24 that add up to negative 2. So think about like negative 4 and 6, or maybe negative 6 and 4. If you add negative 6 plus 4, you're going to get negative 2. So that's the pair you want, negative 6 and positive 4. So now we factored the top and the bottom, and the next step is to cancel any common factors. So we have an x plus 4 on the top and on the bottom. You can only cancel one of the x plus 4s on the top because there's not another x plus 4 to cancel the second one with. So your answer is x plus 4 over x minus 6. You probably don't need to keep them in parentheses, but it's sometimes better to be safe than sorry and just go ahead and keep them in parentheses like that. All right, 28 and 29, we're looking at square roots, which was what we had on the last test on chapter 4. So this operation, there's no operation sign between those radicals, so it's understood to be multiplication. Okay, so the first thing we're going to do is we're going to multiply 8 times 12, which gives you 96, and we have a, if we add the exponents, a to the 8th and b to the 6th. Okay, So first of all, 96 is not a perfect square. And they put it on here twice. That's kind of stupid. But anyway, I'm going to write down my perfect squares over here. 9, 16, 25, 36, 49, 64, 81, 100. That's as high as I need to go. And I'm pretty sure that 36, no, is it 16? I should have brought my calculator. 16 times 6, is that right? 36, carry a 3, 9. Yep. Excuse my scribbles. Sorry. I don't know where the eraser is on this stupid thing. Alright, so 16 will go into 96 6 times. And that's on our perfect square list. Okay? So that's what we're going to use. Is 16 times 6. Now, a to the 8th is even, so we want to keep that the way it is. And same thing with b to the 6th. So our perfect squares are 16, a to the 8th, and b to the 6th. Okay? Now, bring the square roots all out at the same time so you don't get mixed up. The square root of 16 is 4. That comes outside, out in front of the radical. The square root of a to the 8th is a to the 4th because you divide the exponent by 2. Okay? The square root of b to the 6th, b to the 3rd. Out front, that's gone. And the only thing left inside is square root of 6. And that's your answer. Alright, so we just did 96. Well, let's just do it again since they put it here twice. So we simplified 96 into 16 times 6. That's how we're going to break that up. Now, a to the 9th, a lot of people mess up on that because they say, oh, 9's a perfect square. Not when it's an exponent. It has to be even. So this is where we drop back 1 to a to the 8th times a to the 1st, and we keep the b to the 10th because it's an even exponent. So your perfect squares are 16, a to the 8th, and b to the 10th. And now we're going to bring the square roots of those out front. So the square root of 16 is 4. That's gone. The square root of a to the 8th, remember, divide it by 2. That's a to the 4th. That a to the 8th is gone. B to the 10th, divide that by 2. We get b to the 5th. So all of those square roots come out in front of the radical. So, excuse me. So sorry. Did not mean to cough in your ear. What you have left underneath is the 6 and the a. And that, all that mess, is your answer. Okay? Alright, number 30. So, I'm sorry, I'm going to have to take a little drink. Alright, that's a little bit better. Okay, when you add or subtract radicals, they have to be like radicals. Right now, these are not. You've got an 8 and you've got a 32. They're not the same. So we need to see if we can simplify these and make them to be the same radicals, okay, or like radicals. So 8, if we put that on our list of perfect squares, falls between the 4 and the 9. And so 4 goes into 8. We're going to write that as 4 times 2. Okay, so remember that first number has to be a perfect square. And now 32 falls between 25 and 36. You want to go up. The biggest perfect square that goes into 32 is 16 times 2. So you want to go from your number up. Don't go down to your number because you'll find the smallest perfect square. You want to find the biggest. So over here our perfect square is 16. So you simplify each radical separately. The square root of 4 is 2. That comes outside, and you still have the square root of 2 that left on the inside. Okay? Bring down the minus sign. The square root of 16 is 4. That comes outside. The 16's gone, but we still have square root of 2. So now you have 2 square root of 2 minus 4 square root of 2. So you have like radicals. They're both square roots of 2. 2 minus 4 would be negative 2 square root of 2. And that's your answer. Alright, we're getting there. 31. I am going to change this problem because it will not fit on the graph at all. So WebAssign gives us some really stupid problems. So on number 31, change the plus 3 to a minus 3. Okay, make that a negative. So this is what we're going to graph because it just won't fit on the graph otherwise. Alright, so it's in slope-intercept form. The easiest way to do this is remember that the slope, remember this is y equals mx plus b, and the slope is negative 6 over 1. We can write that as a fraction. So you have rise over run, and the y-intercept is that number out at the end. That's negative 3. So the first thing you do is you go to your y-axis and you're going to go down 1, 2, 3 on the y-axis. That's our y-intercept. So from there we need to rise. Look at your slope. We're going to rise 6. So we're going to go up 1, 2, 3, 4, 5, 6. And because it's negative, I'm going to run 1 to the left. If it had been positive, I would run 1 to the right. So you always rise. Ooh, this line is so crooked. Sorry about that. That is really pitiful. Ugh, anyway. I just can't. That's a really bad line. I apologize. Okay, but you get the idea, right? Draw a line through the stinking points. It works. Okay, number 32. Find the x and y intercepts. So 3x plus 7y equals 21. What you have to remember for the x-intercept is that y has to be 0, and the y-intercept, x, has to be 0. So if we plug in 0 for y into our equation, what you're going to have is 3x plus 7 times 0 equals 21. Now, 7 times 0 is 0. That's gone. You have 3x equals 21. Divide by 3. So x equals 7. So there's your first ordered pair, 7, 0. Okay? For the y-intercept, we have to let x be 0. So just remember they're opposites of each other. X-intercept, y is 0. Y-intercept, x is 0. So now into that same equation, this time you're going to have 0 where the x is. So 3 times 0 plus 7y equals 21. Well, 3 times 0, that's 0. That's gone. So we have 7y equals 21. Then divide by 7. So y equals 3. So there's your two intercepts, x and y. Alright, this is it. Woohoo! The last problem ever. I know you're all so excited, and you're so glad that I'm going to finally shut up. Here we go. Find the slope of the line containing the given points. So, the first thing you have to know is your slope formula, which is m equals y2 minus y1 all over x2 minus x1. So in our ordered pairs, the first one is x1, y1, and the second one is x2, y2. Now, when we do this problem, we're going to set up our formula. Okay, we set it up over there. y2 is 5 minus, follow your formula, y1, which is 3. Then on the bottom, x2 is negative 4. Bring down the minus sign. And x1 is a negative 1. So you have to have all those signs there. Okay? On top, 5 minus 3 is 2. And on the bottom, we need to change the signs. So keep the negative 4 and then add the opposite. It becomes negative 4 plus 1. So now we have 2 over negative 3. So the slope, I'm just going to write it over here where it's a little bit more room, is just negative 2/3. So remember, slope's a number, not an ordered pair. It's a number. And that, my friends, is the end of the final exam practice. Okay, so there is a practice final exam in WebAssign. Please take it. It's just like the final. I hope you've enjoyed this semester, and good luck. You can do it. I believe in you. You're all nerds. Get in there and kick that test butt. All right? Good luck.